Today's lesson is on page 63, and it is lesson 42. I'm going to go through some of the examples on this page, which shows you how to work with exponents, and then I'm going to ask you to hand in page 64 for today's work. Question A, we are multiplying x to the exponent of 5 by x to the exponent of 9, and the rule is when you're multiplying, you add the exponents. So we need to add the 5 and the 9 together. And please show your work for all these questions. I do have the final answers for the assignment at the bottom, so I'm asking you to show your steps. Okay, so that's going to be x to the 14. Second question, we have, you want to add the exponents on the same letters with the same base. So the A has a 6, the second A has a 1. We're going to add those together. So 6 plus 1. And then the B's have a 3 and a 5. So we will be adding 3 and 5 together. A to the 7, B to the 8. Question C, when you have coefficients in front of the letters, so we have a 4, we have a -1, and then we have a -9, you want to multiply those first. So if I multiply those together, that will give me 36. And then you want to add the exponents. And the last one has a 1. So we have 11 plus 6 plus 1, which is 18. So m to the 18. And I should have showed my work. So I'm just going to show what I did there. 11 plus 6 plus 1, which is 36 m to the 18. All right, question D. In division, we subtract the exponents. So 21 subtract 7. Question E. We are going to first off divide the coefficients. So we have 48 divided by 6, and then divided by 2. When we do that, we get 4. And then for the exponents, it's 22, subtract 9, and then subtract 1. Which is going to give me 4s to the 12. Question F. Take care of the coefficients first. So 50 divided by -25 is -2. Okay, and then look at the letters that are the same. So we have an x to the 12th and x to the 10. We have division in between, so we're going to subtract the exponents. And then do the same thing on the y's. For the y's, we have an 8 and an 8. So it's going to give a 0. And then the z at the end, we have 4 subtract 1. -2x to the exponent of 2, y to the 0, and z to the 3. And we can go one step further. Y to the 0 is 1. So this entire term disappears, right? It's just going to be 1. So we're left with -2x squared, z to the 3. Question G. Powers of powers. Okay, tell us we're going to multiply the exponents. That happens when you have an exponent on the inside of the bracket and you have another one on the outside. So we're going to multiply those. That's going to give me y to the 20. Excuse me. Question H. This 6 on the outside of the bracket acts on the 2, acts on the A, which has a 1, and then the 2 also has a 1 as an exponent. So really it's 1 times 6 on the 2. On the A, it would be 1 times 6. And then the B would be 2 times 6. So we have 2 to the exponent of 6 a to the exponent of 6, and b to the exponent of 12. Okay, and you can work out 2 to the 6. 2 to the 6 is 64. B12. Question I. Same kind of idea. You have a couple of choices here. You could simplify the d's, right? So you could do division. Okay, subtract the exponents to simplify it a little bit. Why don't we do that actually? I might do that first. So we have c cubed, d4 and d3. We're going to subtract. That's going to just give us d1. And then at the bottom we have an e and a 2. Okay, now we're going to bring that 5 in, and it's going to get multiplied with every single exponent. So I'm going to move over here. I have a little bit more space. So I have c cubed. That 3 will get multiplied by the 5. d1 gets multiplied by 5. And then the 2 has an exponent of 1. And the e has an exponent of 1. Okay, so simplified, this is c to the exponent of 15, d to the 5th over 2 to the 5th, and e to the 5th. And if you want to go further, you can expand that to 5th, which is 32. Oops, that's supposed to be a d. Over 32e to the 5th. All right, question J. G to the exponent of 0 is equal to 1. All right, anytime you have an exponent of 0, it's equal to 1, the whole expression. K, same thing, 23 to the 0 is 1, 32 to the 0 is also 1. So this is going to give me 2. Right, this entire base is to the exponent of 0. So that's going to be 1. Okay, question M. Negative exponents, how do we deal with those? Well, right now, the expression is over 1. If you want to make a negative exponent positive, you bring that term with the negative exponent down to the bottom, and that makes it positive. So it's 7 cubed at the bottom with the 1 over the top. Now it just says simplify with a positive exponent. So we don't really need to work out what 7 cubed is. I know I did work out some of the other questions above, but it's not necessary. Question N. If you have a fraction with a negative exponent, we're going to change the location for both of those. All right, because if we brought that negative 1 inside, it would be 1 to the negative 1 over 2 to the negative 1. Each of these are negative, so they both have to switch places to become positive. And when we do that, the exponents become positive. So this is just equal to 2. Okay, question O, same thing. This is 3 to the negative 2 over 4 to the negative 2. Switch the location so that they become positive. And we've got 3 more at the bottom here. P, we've got powers of powers. So I would work out, when you have negative exponents, work out use the exponent rules if you can. You know, powers of powers or division or multiplication. And then worry about changing your negative answer at the end to positive if you have a negative exponent. Don't try to change this x to the negative 8 to 1 over x to the 8. It just gets messy. So powers of powers means we're going to multiply. Negative 8 times negative 2 gives me 8 to the 16. And look, we end up with the positive exponent. We didn't even need to change anything here. Q, 2 to the negative 1 is 1 over 2 to the positive 1 plus 1 over 3 to the positive 2. Right here, we couldn't use any exponent rules because the bases were different. We had a 2 and a 3, so I had no choice but to focus on the negative exponents. And then 1 over 2 to the 1 is just 1 over 2, and then the second fraction is 1 over 9. And now it's just a common denominator of 18. That's going to give me 2 and 9. So the answer is 11 over 18. And the last question. Here I would take care of the coefficients first. So we have a 12 times 5, and then divided by 15. So 12 times 5 is 60, divided by 15 is 4. So we have a 4 for our coefficients. And then you could use the multiplication rule where you add the exponents. So we have an m to the 5, m to the negative 10. So we're going to add the exponents. And then for the n's, negative 2 and 4. And then I'm just going to rewrite the bottom the way it is. The 15 is gone because we already took care of the coefficients. Oops, that was an m. Should be an n. N to the negative 4. All right. So that will give you m. Exponent 5 subtract 10 is negative 5. And then n will have a 2. And now we can use the division rule to subtract the exponents. Okay, so the m's, we have negative 5 and a 3 at the bottom, so subtract 3. And then we have an n with a 2, subtract negative 4. Which is 4m. Negative 5 minus 3 is negative 8. And then on the n, we have 2 subtract negative 4, which is like 2 plus 4, which is n to the 6. All right, one more step here. We have a negative exponent on the m. So what I'm going to do is just bring that term down to the bottom of the fraction, and it will become positive 8. And that's it. All right, so those are your examples for today. If you wouldn't mind working on page 64, trying some of these questions, show a step for each question, please, and then you can check your answers at the bottom. All right, have a super day, and I'll see you tomorrow. Take care.